that you will have, I want to request that you will have somewhere to write, because there are key things that I would have loved every student. You may not get these slides quickly, but I want you to be part of it, because one aspect that every student should understand with the paper 2 is that for any student who should be able to excel in this paper, you should pass this paper at least, you should pass this question with the 23 and above if you are to be safe. When I say safe, I'm talking of excelling, not passing, because if you get in a lower grade, one would say you have passed, but we want you to excel. So the tactic behind of all of this is that you must pass, you must be able to excel in this question 1, which is compulsory. The unfortunate part of it, like unlike in paper 1 and paper 3, paper 3 you may have multiple 3 questions, you choose one of field work. Paper 1, you may have photograph and you also have map work, which are all compulsory. The unfortunate part of it, of this paper, is that they only give you one question. So you either have read it or you have not read it. So that is why I want to encourage that we are all together and we go slowly but systematically, and we are sure of what we want to have. Now, apart from us having only the methods, there are also things that I would have loved every student to first of all understand. How do I get marks? When they set a question of 25 marks, for example, under statistics, it may not purely be that the methodology is going to take all the 25 marks. You will find out that maybe the methodology is going to take maybe 8, at most 8 to 12 marks. And then the other questions can be either looking at the advantages and disadvantages. It can be a question of section B, maybe the factors that have contributed to that. But we shall later on look at that. But I basically want us, first of all, to share, and allow me share with you. Yes, I want to think that is, yeah. Just a minute, just a minute. Seems I'm not sharing from the right source. I'm not sharing from the right source, which I would have loved to share. I have to close up something. So it is important that a student has something actually that you are able to write something down, so that it does not mean that I just, if I'm here and I just come and try to go through some of these things, it may not really make value. And that's why I want to encourage that at least every student should be able to. I want to think you should be able to see my screen. Are you able to see my screen, please?
Yes, we see it so clearly.
Yes, sir.
Okay, I just want to, it seems I'm forgetting my little ICT. I want to run the,
Hey, you
I
want
want
to
to run the
slideshow.
Okay, from the beginning. Yeah, the slides. Okay. So like I have shared, I want us to understand some of the things that statistics or statistical geography is a collection, analysis, and presentation of numerical data. Or it is information that is in form of graphs, charts, and maps. When we talk of statistics, we are looking at information can be gathered, but this information is analyzed. But after analyzing the information, this information should be able to be presented. But the presentation is going to be in numerical. In a numerical, something that you're not going to see, you're going to see figures, you're going to see things like graphs, you'll see things like charts, you'll see things like maps. I want to think every one of you has seen graphs. The question may only be, what is this graph? What is this graph? But they are all graphs. Some of you have seen charts. Charts, they grow sometimes in your classrooms. You have seen wall charts. They are put on something. Some of them, even you don't understand them, basically because maybe you did not know. Then you have also seen maps. They are quite different maps. You will see some maps which show maybe aspects of forests, soils, types of soils with some coloring. At the end of this course, I want us to appreciate that we shall go through some of these things and understand exactly what it means and what one will do, look at. Then statistics shows geographical facts that are difficult to understand by mere looking at the data given. Now, you will find out that we shall get information, which information is in raw data. When I talk of raw data, is you will find maybe 10, 11, 1 million, something like that. That is information. But we can change that information from its normal state to a diagram, to a representation, to something. We can use the colors, for example, to shade where there is only, let's say, population in an area which is all having maybe 10,000 people within Uganda. And therefore, you will find a map which is having a coloring, maybe in one area, maybe in about 5 areas with the same color, meaning that that particular area is having particular population, maybe 10,000. And you find an area also having another color, maybe showing population of 20,000. When we look at all of those things, it is one thing that is going to help us now to start understand. And therefore, at the advanced level, you should now be able to understand when we talk of this, when we talk of samples, when we talk about this. Two, all of these things we are trying to go through, there are areas where we focus at, but you cannot know those areas unless if we have come to understand this. Two, I also wouldn't have loved to have students who are passing exams to go, but we want to have good parliamentarians tomorrow. We want to have good statisticians tomorrow. We want to have good doctors who can be able to interpret what it is. So some of these things that we want to go through, we want to go systematically, but understand them. Now, what are the uses of statistics in geography? It could be one. I don't know what the rest of the students think. But one of the things I would understand is that statistics in geography, first of all, it is part of the syllabus of secondary syllabus, A level. Thus, it benefits both you, the student, but even us, the teachers, for getting geographical skills. Like I have said, there are maps that you have not been, or that you did not know what possibly they mean and how they reach there. After this course, you should be able now to start interpreting that this one is a base map. This one is a flow map. This one is this kind of map. This one is a circular graph. And how do we construct them? So it is one aspect. That is why we are struggling. Apart from, let's not look at the other aspect of you passing the exam, but there are things that you also look at. The other one is that some geographical information or facts may not easily be understood when it is actually in the figures. So in a sense, statistics provides a basis of understanding such facts. And when the geographical, or when they are in graphs, or when they have been presented as diagrams. There are information, there is information that you have already seen, maybe when they are portraying population of Uganda, and they draw graphs, maybe they have put something, they put a circular graph showing some activities that have taken on vis-a-vis the area. And maybe we have only just been looking at them and saying, oh, what are these people talking about? At this level, we expect, that is why our constitution says for anyone to be a person who has finished, to be an MP, a member of parliament, you must at least have done senior 6 or its equivalence. The reason behind is that you have looked at some of these things. So you should be able to look at what could be the causes, what could be some of these things. So at the end of this course, we should also be able to understand all of this. The other one, it is also important that statistics makes it easier for us to come up with comparisons, which are important in geographical studies. For example, you should be able to compare climate variations or climate differences of desert regions with equatorial regions, and then maybe also analyze. You will later on find out that we shall have statistical methods actually which will be giving a representation which you can superimpose, which you can put on a map, and therefore they are showing population. At the same time, they are showing the area, and maybe they are also giving some other things, maybe in the races of people. You can have population of people, but also know the coloring, all the races. Maybe these ones are these in the countries where we have that. Or we shall also have like circular graphs where we shall have temperature represented, rainfall represented, at the same time, activities, all crops being grown. So when we have such kind of things, they can help us to understand that if this area receives a lot of rainfall, then there is a likelihood that there are particular crops that grow as a result of too much rainfall. Or if there is a particular season, for example, maybe between July and August, you will find out that people are carrying out harvesting. So it has a connotation behind that because of it being a spell time, or because it being a dry season, that's when people carry out what? The harvesting. So that's what we are saying, that we shall look at the two and compare. So it helps us to make comparisons. And you look at, even when you look at bar graphs, you should be able to know that in maybe what in this year, if they were producing copper was produced at this rate, and this one was at this rate, and then we move on. So among others, we also have statistics trains students on data collection, analysis, and presentations. For example, at the end of the day, you will also appreciate that you should be able to know how do you collect data. When we say collection of data, is that you can be sent. Recently, they were asking people from different areas of Uganda to go and carry out data collection about animals. And you do just go and fill in how many cows do you have, how many goats, how many hens. That is data collection, if we wanted that. But during given times for census, they have students. I have known many of my students whom I have recommended to go to act as those people who get information from there. And later on, that information is put into a program, different programs, but we can have many, maybe SSP program and something of the kind. So when that data is brought, it is raw data. The data, when the data is brought, is raw data. Later on, that data is, when it is put together, it now helps us to analyze. We now start interpreting what is the population of Kampala, what is the population of Chotera, what is the population of Kabale, and why. There are reasons we shall give because of the data you have. But when we are doing out all that, this data and its analysis, wow, in the background, I don't know, I think there should be someone who is, I don't know whether, anyway, the data analysis and then the presentation. This data, when we collect data, data is always there for, we do it for a purpose. We want to give this information to a particular group of people, maybe who are going to know about population, the increment of population or the increase in population in a particular year, and then maybe also try to do the planning, and they know how they will work out. If it is an aspect of knowing, for example, rainfall, we may want to know what is the rainfall totals in a particular region. If you look at people who work out on meteorology, for you to be able to do meteorology at university, you must have done geography. And therefore, one of the aspects that you will also need to understand, you are supposed to give information to the pilot. And therefore, the pilot can never and never at one time go into the sky or try flying without him getting information of knowing what is the weather like and their aspects. For example, why is the wind blowing and what? All of those things have an implication, especially as far as the meteorology department is concerned of any country, not only in Uganda. So when we are able to do that, then we should be able, examples may be like having the data about rainfall, temperature, population, and this partly equips students with the skills of describing geographical facts, which geographical facts may be rainfall, maybe temperature, among others. So among other things we can also look at it is that when we study statistics, it improves on the student's accuracy and neatness. In this practical part of geography, students exploit talents in the areas of mathematics and also drawing. We shall later on find out that one of the aspects for you to be able to receive or to get some marks, there is accuracy. And actually we look at the word tank. If you write the word tank, wherever you are, in this level, I will tell you that tanks, we use it for tank. A stands for accuracy, N stands for neatness, K stands for key, and S stands for scale. That is the summary. Tanks, the word tanks. T stands for title, A stands for accuracy, N stands for neatness, K stands for key, and S stands for scale. So for methodology that you are going to have, those key things must happen there. And that you will find out that at particular they will say accuracy 2 marks, neatness 2 marks, key 1 mark, which will give us a total. That is why in an examination you will find out that they give them, they mention, they label the question and also give the mark. The reason of giving the mark is that the student should be knowing that when I am doing this question, this is the mark allocation which I have onto this. So at the end of the day, statistics is going to help us to be neat, to be accurate to particular things. And especially there will be strictness on particular methodologies when we get on board. The other is that the application of mathematics in geography tends to break the boredom. That results from not far from science subject when we give the statistical calculations and the rest. We shall appreciate that some of these things help. And as we are presenting, as we are looking at this, it more or less becomes a simple thing. And I have always told my students that please let's not have this biasness. Sometimes students reach when you have some calculation, then they say, Master, I think you have again brought mathematics. No, there is nothing like mathematics in geography. But at the back of the mind, there is somebody to apply the information. And that's why I always encourage my students that please, we are not applying mathematics in geography, but we are applying geography in mathematics to pass this subject. So it is key and important that when we are looking at this, it is going to help us bring closer things that we may feel is hard, but go systematically and get to the point, and then we should be able to use that. So now, we have different methods, and these different methods are grouped into 3. One of the group that we have where we have information is what we call as statistical graphs. Under statistical graphs, we have 6 methodologies or methods, and one of them is a simple line and bar graphs. A simple line and bar graph. Under simple bar and graphs, the construction, we shall look at this later, is that it's almost the same. The only difference is that the other one, when you are doing the construction, looks and concentrates on the drawing of lines. While for the other, the bars, you are going to concentrate drawing using bars. The information in most cases which is required in here has to do with little information. Sketch something, representation of this, maybe particularly one item. That is for simple bar graph. Then we have what we call as group or comparative bar graphs or comparative line graphs. The difference is the other one you use lines, the other one you use bars. So when we talk of comparative, is we are having more than one, and therefore you are drawing lines. These lines are supposed to be used for comparison purposes. That's why we are calling it as comparative graphs, or sometimes they call them as grouped. That is why we have it under statistical graphs. They are all graphs. Then the other one is a compound. Sometimes it is called cumulative. Sometimes it is called divided bar graphs. It is also under statistical graphs. What we are looking at under here are graphs that show statistics. They are in form of graphs. So all of these ones I'm trying to talk about. Basically, look at that. Then the other one we also have is a divergent line or a divergent bar graph. I've grouped these because they are almost the same. I've told you that the difference is only in the representation. In lines, we use line to represent. In bars, we use bar. So if we talk of divergent, then we are talking of something that is going up and down, divergent, they diverge, upside, downwards, all positive and negative. So when we look at this, we shall find out that you can have information which is actually, which requires you, which has both the positives and negative. And we shall look at them. How do you calculate? We get all of the totals, divide them by a number which is given, and subtract on some figure to be able to get those figures. And in those figures, you will find out that you have some figures which are positive and some figures which are negative. So the positive figures are represented up of the graph, where we have a 0, and then the negative are represented down. Some of you could have seen some of these graphs, but maybe you don't know. But now when I talk about them, I want to think you are now appreciating and saying, hey, this is the other one. Then there are these other common ones that a number of us have seen, the age and sex graphs. Sometimes people call them as population pyramids. I think these were common at the ordinary level. You must have done some of them, but the other word is. So these kind of graphs represent particularly population. You cannot use a sex and age graph to represent something else apart from population. The population can be population vis-a-vis 2 years, which we call as compound sex, age, and graphs. We can have all of those ones. So sometimes, like you have seen exams, and even sometimes under examination, national examination in NEB, they can sometimes they have asked the student use the suitable, use the suitable method to represent information, and they have given population of age and sex. So it means that you are already linked, and sometimes the examiner may want just to test and know if I gave this kind of information, is a student able to understand? That is why I've said that we need to go slowly, but very sure. And under this, I will always tell my students that please master 2 things in statistics. 1, know what this method requires. 2, also understand that what are the procedures of construction, because those are the key things. And I don't want you to say, I will depend on the other one. No, you either know or you don't know. And if you know, you will do the work. If you don't know, you will not be able to do the work. Then the other one that we have under statistical is the circular graphs. Circular graphs look like a circle, and sometimes they can be, they represent information in terms of temperature, in terms of rainfall, but they can also have both temperature and rainfall, but also they can also have temperature, rainfall, and at the same time, agricultural practices. So you may have seen some of these, and I want to think that maybe you have also had this. So that is basically what are under statistical graphs. Now, the other one that we have are the statistical charts and the diagrams. I want to think you are not getting confused. Statistical graphs. The other ones are statistics, but they are graphs in statistics. Now, these ones are in statistics, but they are charts and diagrams. So one of them we shall have is the divided circles. Divided circles. You will see some circles, but those circles are divided. Sometimes some people have called them as pie charts. And I have always quarreled with my students that sometimes when you are teaching students who do MEG, when they come to geography, they don't want you to call it. That's why I said, the words of geography should be maintained so that we don't bias people. So, but the divided circle, under divided circles, we have 2. We also have compounded divided circles. We shall look at them when time comes. And then we have divided rectangles. They are rectangles which are divided. Now, under divided rectangles, we also have compound divided rectangles. But they are all under statistical charts which are divided rectangles. Such information represents things to do with the cultivation on land, especially on aspects of land, maybe in acreage or something like that. That is what we look at. Then the other one we look at are the proportional circles. Proportional circles, it is also under the statistical charts and diagrams. And then the other one we look at also are the proportional squares. Now, proportional squares, the difference is the other one are represented in squares, the other one are representation in circles. We shall look at a number of them, and we shall appreciate that it's good. That is the second version. We said we have statistical graph. Then the other section we have are statistical charts and diagrams. And then the last one are the statistical maps. There may not be many that maybe a number of you have seen, especially at ordinary level. But we have what we call as dotted maps. And the dotted maps are maps which you will find that they have been, the representation is by use of colors or use of lines that strengthen. So it is also one of the methods. And then the other one is shaded. Please, there is something that is shaded maps, not shaping maps, shaded. So it is not EP, but it is shaded maps. So you will also find out that these are maps, but you will find that we are using the same color, but the difference is in the thickness. For example, areas which have population of 10,000, we shall use the same color, but its coloring is going to be thick or thin. Then if we are doing some other thing, it will continue like that. Those are what we call as dotted, shaded maps. Then the other ones are flow maps. Flow maps are, you have seen some maps which exist, and then you see something moving from one area to another. I don't know whether I have a picture in this booklet of mine. I would show you, and you see how flow maps look like, so that, but I know we shall get there. So you will see some drawing somewhere, and at the end of the day, you see that drawing moving with some arrows from some area moving to another area. I don't know whether I can get there, but we shall reach there. I know that we shall be able. That is also one of the ones. Then we also have others which are called as isoline maps. Isoline maps are not very common, and sometimes many schools dodge. I don't want to say they don't teach them, but many schools dodge to teach them. Yes, please.
If you want to show with the book, the one in the book, you need to stop sharing, such that the picture will become bigger for the book.
Okay, maybe I will do that. Let me first finish. I will do that when we have time, because I'm seeing time is running. Yet I wanted us to do something. So isoline maps are lines that join, are equal lines that join from one area to another. For example, you can have a map which has maybe same lines of temperature, same lines of something, and they are having 100. So you just get a ruler and join them from one to another until when you look for all those. Those are what we call as isoline maps. Then the other one that we have are what we call as repeated diagrams or repeated maps. These are almost also the same, only that you keep using the same symbol to give the representation. Everything that I have talked about, if you have been able, these are 5, these are 4, and then these are 6. All of these ones are examinable at senior 6. They can set anything. It is not a question. That's why I say that when we are looking at statistics, every student should be very focused, try to do everything, and because any of these ones can be set. I have always told my student, and I still want to say, that unlike in paper 2, section B, where you are not sure, at least you are sure that there will be a question that will be set and which will be among these 14 sections. So a student who is very okay, you have to read through these methodologies, understand them, and try to go through them and try to see your way out. It is very possible. They will not say something different. It is not a question of saying that they will bring another question. No, they will be among these ones that we looked at. So basically, that is what we wanted. I wanted to know whether there is any question. If there is no question, Ayub, I don't know how our time is moving, but I wanted to find out if the students have a question. I would first maybe give something so that we now we start with one, which are the simple bar graphs and simple line graphs, and then we go through them and then we see.
Okay,
so I wanted
let's
us to
check
think
if there are any questions that are coming in immediately.
Okay.
That room doesn't have a question, but I see Mutsinzi, Joshua has raised the hand. Joshua, please go ahead. Joshua, unmute.
Yes, teacher.
I see that you have raised your hand. Do you have a question or comment?
Teacher. Excuse me, teacher.
Hello?
Teacher,
yes,
you
you're
getting me?
excused. Yes, we are getting you clearly.
Yeah. Where do windrows fall?
Where do?
Where do windrows fall? Windrows.
Yes, where does the windrows fall? And Xperia Ultra.
Yeah.
Okay.
Yeah.
So Xperia, there is someone who had a hand up. Okay, has put it down. Okay. Brother Dominique, where does the windrows fall? Yep. Ultra, go on. Ultra, you may want to rename yourself so that we can identify you. Ultra. Okay. Where? Brother, you can proceed.
Hello.
Hello.
Okay. The question that has been raised, the windrows follow under the statistical charts. It's only that I think we did not capture them, that they are supposed to be there because they are charts and diagrams, the windrows. I don't know whether some other students have seen the windrows, but they are sort of like a compass direction which has some arms. It's an observation. They follow under statistical charts and diagrams. Okay, fine. So if there is no question, I want to think we are progressing on. Now, we want to look at simple bar graphs. Some of this information that I'm trying to look at, I wanted to start with this because every student, if you attended geography, which I want to know that geography is comparison at ordinary level in Uganda, even in Tanzania, even in Kenya, you must at least have looked at what they call as bar graphs. And we are saying that this may be drawn by or in both vertical and horizontal bars. Not many of us have been or are familiar to the horizontal, but they exist. If you look at some books, you will find them. And I will share with you some of the materials that I have, especially in some of them, and then we see. But we are saying that the most common method that is used are the ones we have already seen, the vertical ones, the vertical bar graphs. They may be used to social statistics that cover a number of years. It can be months. It can be any other item that is given. It can be mean annual rainfall, maybe runs from January to December. It can be Uganda's tea production in tons from this year and the other. It can be any other item that is given and they require you to give that information. Okay, then the statistical graphs is a graph of statistical methods which deals with the relationship between dependent and independent variables. When I talk of dependent and independent variables, it means that one of them bases on the other. For example, if you want to have music, if you want to play music, you will need a speaker and maybe I'm forgetting how they call it. How is it called again? When you want to play music, you will need a speaker and then maybe an amplifier. I don't know when I want to use that one will give us something. So for the music to flow, or for the music, for you to be able to listen to some music, if it is I'm using this at a situation of being that it's a big function. You will need some music, you will need an amplifier to give you the sound. But the amplifier, you will need a loudspeaker to give you the sound. But the loudspeaker must pick information from the amplifier to be able. So it means that of the two, which one depends on the other? Those are questions that I wanted to know. And I want to ask, I want to open up. That is one thing. Two, sometimes we have also seen that you have crops. On assumption there is no irrigation taking place. You have crops and the yields, but you also have rain. When you have a lot of rain, you have high crop yield. On assumption, leaving other factors constant, I want to understand from the student which of those two things depend on the other, and I will explain this one. Kalema, assist me open up on to, I want to listen to some two people. Hello?
Hello?
Yes, I want to understand from the two scenarios. Any student to help us, I want to know which one depends on the other.
Okay. Students, the challenge is now yours. The ball is in your court.
Anyone who can give us his suggestion or her suggestion on those two things? I have a loudspeaker and an amplifier. Which of the two depends on the other to have the music? That is one scenario. The other scenario is having a lot of rainfall and high yields. Which of the two depends on the other?
Okay. Let us, okay, we have Joshua. Joshua, please go ahead. Joshua, you have an amplifier and a speaker. You want to play music. Which one depends on the other? Is it the speaker that depends on the amplifier, or the amplifier depends on the speaker? Vivian is said. Vivian, go on.
The speaker, the amplifier depends on the speaker.
The amplifier depends on the speaker. Okay, that is your view.
Yes.
That is Vivian. Can we take on another one?
Do you have another one? Stephen?
Yeah, from your explanation, the speaker is the one that depends on the amplifier. Since
that is Stephen has given.
Since the amplifier is the one that sends information to the speaker.
Okay. Okay, thank you for the rest of the members, the students maybe wanted to give. I wanted to explain this thing in that kind of scenario. When we talk about
with the rain and
okay.
Okay. Yeah, because rain and the harvest.
Rain and the harvest. Which of the two depends on the other?
Lamra, Ndagire, Lamra. Which one? depends on the other. Lamra, unmute. Ndagire, Lamra. Oh, maybe has. Let me check the comment. She could have written the comment here. Okay, let's see. I think Lamra is not able to unmute herself, but in the chat room, I see Simon has written, the harvest depends on the rain. Okay.
Harvest depends on the rain.
Yeah, that's what he has written.
Okay. Now, I wanted to explain that. I wanted you to have that picture so that I'm able to explain this issue of the relationship and how we relate with it in the statistical graph. When we are drawing a graph, we have one thing represented on one axis, or lines. The vertical lines, I want to use the geographical word so that I don't use mathematics and I scare some of my students. We have one line which runs from up to down, which is the vertical. And then we have one line which runs from east to west, down, which is the horizontal line. When we are drawing graphs, we shall always find out, especially around the statistical graph, that information which is given there, one information relies on the other. There will be something that is dependent, which actually in that sense will only exist because the other is there. For example, crop production. This information, all of these things can be in crop production, it can be in output, it can be in exports, it can be in population, and many examples. And I'm saying that these are dependent variables. It means that, for example, in the other aspect which I was saying, the right thing was that for the amplifier is the one which feeds information to the loudspeaker. Therefore, the loudspeaker is dependent on the amplifier. The amplifier is independent. I don't know whether you get my point. However, I am trying to explain in this aspect. I'm not saying we are going to examine this, but I wanted you just to understand. Because when we come to draw the maps, I mean the graphs, is that we should understand what should be where and when. So I am explaining that in this aspect, that the examples of dependent variables are put on one side and the other are on the other side. And these can be in the different things. For example, the independent variables can be in aspects of years, months, weeks, countries. We shall look at this in the example. There are basically two types of statistical graphs. Remember, we are looking at statistical graphs, but one of them is bar graph or line graph. And I have said that the bar graphs and the line graphs have the same. The only difference is that when we are drawing, the other one we use bars, while in the line graph, you are going to use lines to represent the information. Let's go down. For example, when we look at this, so let us look at the construction procedure when we are going to draw a bar graph. Let me first use one, because for the line graph, I will explain, but it's the same procedure. We are saying put the independent variables on the horizontal scale and the dependent variable on the vertical scale. So the one which depends should be on the horizontal scale, and the one which is independent, it should be on the vertical scale. I have explained in the other one up. 2, the origin of the graph should be at 0. If we are drawing the graph, and I've told you that the graph has the vertical and also has the horizontal axis, or call them lines if you don't want to call them axis. The line at which the horizontal and the vertical are joining should start at 0. As it goes, 0, 2, 3, 4, all of 0, 10, 20. Some students just put it and say, it is okay, it becomes as if it's something. But anything on a graph should start from, even in paper 1, there is something that we have shared, which they have to look at. So the height of the graph should be at, at 0 where it starts, and the height of the graph should be slightly much more higher. For example, if we are going to draw, I want to think you should be able to see this. I don't know whether it is clear, but if it's not, let's just be accommodative. If you look at this area, I'm saying this area here, if you are able to see this, this is my 0, and we are moving up. This is the vertical axis, or the vertical line. Then this one here is the horizontal line. Now, on the vertical line, we are representing, for example, in this graph, we are representing temperature, which is dependent on the month. Every month which exists has some temperature. Now, in this aspect, we are saying, in the month of January, for example, if it is temperatures for Uganda, you will have high temperatures in areas like Eastern Uganda. And therefore, we are saying because of January, you will find that the temperatures are going to be maybe slightly much more higher than when they would be maybe in another particular month. So the month which exists, for example, this month here, will produce values or will produce temperatures in relation to that particular month. The month of January cannot give us the same temperature of February, and it cannot give us the same temperature of December. So it means that when you have the month, it will give you some values depending on what. So this one depends on the other. So you start from here, and this is 0. That's what we are saying. But we are saying as you go on, which we shall go through the scale, this graph should not only end here. If the last figure is 36, then it should slightly go high, so that you don't only end here and it is even, especially on these other simple ones. Okay. Then we are saying that the other one is that you do not write bigger numbers on your scale. For example, 10,000, 1 million, but instead indicate them on the top of the figure, which examples can be in metric tons. For example, we have this. You put that in quotes if you want. I don't know whether that's the best word. In quotes, like this one here, we are having here, to make sure that you are trying. So instead of writing a million, you write them, but they should be at the upper area of the map, or I mean of the graph you are drawing. So it should not be represented and putting all of the million that in 1,000 millions. That will be higher for us to understand. Then calculating the scale of the graph. In the case of vertical bars reading of the graph. Let's now go to calculation. For example, we are saying, how do we calculate the scale? Start from the right, the left to the right. Beg your pardon. This is not for calculation. I think there must be something that is no. Horizontal bars are used when the aspect of time is not significant. For example, the table having information for various exports of the country and their quantities. So this one, you remember I was explaining that if you have horizontal bars, horizontal bars are graphs that are drawn, but the drawings are this side, which I said is not very common. But I'm just giving an example because you never know. You may see them at some other level. For this time, let's not concentrate on this because it may in one way or the other confuse you. So the other one was saying that the title of the graph should not be forgotten. I beg your pardon. The title of the graph is gotten from the question that is asked. For example, you are expected to write the title for any graph you write, or for any diagram you write, or for any chart you write. Where do I get the question? The question I mean the title. The title is got in the question. For example, we are going to look at the question down there. I don't know what. For example, that is the information. That is data which has been given to us. And they are saying the table below. There must be something here, which is what there should be a T. The table below shows the mean monthly temperature of the Ugandan town. That's the question. And they have asked us to draw a simple bar graph to represent the information. So when we are going to get the title, like I've been explaining in this, then the title is got from the question. So it should be a simple bar graph showing the mean temperature of one of the Ugandan towns. I don't know whether I get my point. So usually the title will be got from the question. Just as the question has been asked, a simple bar graph, a circular graph showing in millions, you should copy it as it is and bring it. Please avoid the situations where students say represents. No, it shows. Because to represent is you have already now got it from the form, the raw data, and you have pushed it into now a much more you organize the information. So for the title, I think we are clear. Now determining the scale. To determine the scale of a graph is dependent on two things. One of the first things is that the student must first of all have in mind of what units he or she wants to use. You identify the highest value. For example, in this aspect, what is the highest value? I think the highest value would be this one, 36. So when you are given information, you first look at what is the highest overall highest value. The highest value is going to help us to determine the scale of the vertical. I mean to determine the scale of which we are supposed to represent on the vertical axis or the vertical line. So when you are able to see 36, for example, in that aspect, then we are saying that you should be able to look, I have said, identify the highest value, which now in that case with 36 or the figure, the units that you have been given, or the figures that you have been given. Then you divide them by the units or the number of units that you wish to use. Now that's why I said that the student must be able to take himself to determine which units do I want to use on the horizontal. When I talk of the units, I am talking of these ones. I want to think if I'm able to see this. For example, when you see from here, it is 0. From 0 to this is 1 centimeter, that is 3. Another centimeter, another centimeter, another centimeter, until when you reach. For example, me here, I have 12. If you look at this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've chosen to use 12. So it will mean that I'm going to get 36 because it's what I've got as my highest value, and I will divide by 12 to get the scale. But there is an observation which I want to say, that usually your graph should not be tiny and small, and therefore it should also not be very big. That's why I've said that it should range between 10 centimeters and 14. Why? Because beyond the 10, it means that that graph will not be able to fit. If you look at the UNEB paper or the UNEB, the graph book, let's say the graph papers that are supplied by UNEB, which they give. On the horizontal axis, it has, I think, 24. The vertical axis, it has 16. But at the top of it, you must leave some space for writing the title and the down. So it means you remain with about 16 or 14. So if you go beyond 14, it means that graph is not going to be able to reach. That's why I put here that when you are looking at that, try to use, if you are trying to get you get between 10 and 14 centimeters. Beyond that, it will be big. So let's look at that. Now, let's go into the simple issue. We have said that, for example, for me there, I have got the highest as 36. And I am dividing 36 by 12. 36 is the highest unit I got of the data which I was given. 12 is what I am choosing, meaning that on my vertical axis, I am going to have 12 centimeters to represent. So when I get 36 and I divide it by 12, it should be able to give me what? 3. So I am saying that therefore, each of that 1 centimeter on the vertical axis will represent 3 degrees, which we are later on going to see. Then I'm saying that after you have determined your vertical scale, now you know that every 1 centimeter on the vertical axis or the vertical line will carry 3, meaning you will get from 0 to 3, plus another 3 is 6, another 3 is 9, another 3 is 12, another 3 is 15, another 3 is 18, another 3 is 21, another 3 is 24, another 3 is 27, until when you reach the last. By the time you reach the last unit, you should be able to have 36. My cursor is having a problem. Not able. For example, when you look here, this is 0. My next unit here is 3, 1 centimeter. Another 1 centimeter is 6. Another centimeter is 9. Another centimeter is 12. Until when I go up to the last. So when you get the highest unit of 36, for example, that's the one I got, and you divide it by 12, I should be able to have 3. And if I get 3 times the 12, I should be able to get the 36. So my last figure here on the topmost area of the graph should be 36. That is why I got. So you can also determine. I'm not saying you should use mine, but I have given you that you look for the highest unit you have, in this case 36, and you can decide to divide it by 2 or 4. But like I have said, I mean to divide it by 10 or 14 or 9. But like I've said, your graph should not be very small and your graph should not be very. So that one is dependent on the student. The student also must take a measure to see which one to use and that what type. So that is what we are trying to. Then after you have got the vertical scale, we are saying draw the vertical axis and the horizontal axis line. What I'm referring to as the vertical axis line are these ones. This one here, as you see it, that is the vertical. And then you also draw this one, which is the horizontal. Excuse me. It is important to close up your graph so that you don't only draw on one side. You have to draw on both sides, this side and also this side, and then draw. These are the ones I'm calling as the vertical axis, and this is the horizontal axis. I want to think we are moving together. Then we are saying that using a ruler and a pencil, draw the bars as per the figures given in the table. Remember, our figures are here. Here at the topmost area, you have given us months, and the months run from January, February, March, April, May, June, August, September, October, November, and December. Then the downer area, they are giving us temperature, which temperature the representation is supposed to be in degrees Celsius. And they have given us, for example, figures for January is 12, figures for February is 13, figures for March is 16, April is 18, May is 23, June is 26, and others up to. This one here is the question. Draw a simple bar graph. It's the one actually that I am looking at if you followed up. So after drawing this and you also draw this, the next thing now is to label this. You already got the scale because you got the highest, you divided it by the units you want. And in this case, I have got 36 divided by 12 as a unit I want to use on the vertical axis. It means that I'm going to draw. I'm going to label this from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So here is 3, the next is 6, like I have given. Now, on this axis, you will also now have to divide this. Remember, these are 12. So you also decide to give them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 12, representing the month. So you write January, February, March, April, May, June, July, up to December. When we are through with that, we should make sure that for us to have our units, for example, as we're having it the other side, they have told us for January, we want to represent 12. So we shall get onto our square, our graph paper or graph book and draw the 12. I'm having a problem, a challenge with my cursor. Okay. So you get your ruler and pencil and draw up to here. Because if you check, this is 6, this is 9, this is 12. So you draw from here to here and also draw up to here. That is a representation for January. When you are going to the next one, you should leave space. And the space must be equal. Me, I have decided to leave 0.1 millimeters because there are many. What we are supposed to represent on the horizontal axis are quite a number of them on here. But assuming they were like 6, you can even decide to leave 1 centimeter. But because of this, you will see that there are spaces I've left here. So you draw that, you go to February, also you draw, if I think here they have given us, which is I think 18. If we followed this, it's 13. You will also draw for March, you also draw for April until when you go up to December. And then you should be able. Now, the labeling should be done. This area, the whole of this horizontal should be labeled as months. And then this area should be labeled as temperatures in degrees Celsius. Now, don't forget that you have used the scale. And the one who is going to interpret, all of the examiner, who is supposed to interpret this question, must know what scale did you use. So you will put here that in, you have seen here, vertical scale is 1 centimeter represents 3 degrees Celsius. Then the horizontal scale is 1 centimeter. If you have used 1, represents 1 calendar month, or represents 1 month. That is ideally what it will call for. So in here, if we are to go through it, I have said make it a point to leave a space between each bar. It's what I was trying to explain. Then the other one is label both the horizontal and the vertical axis with their representation. That is why I said that horizontal should have the month, and then the vertical should have the temperatures. So as I have said that the explanation, but the explanation, it's only that we are not aligned, but the explanation is this. This is the representation that we have tried to give, and then one should be able to have everything that is able to see. So maybe I can stop there. I don't know whether what time do we have? It is 4 already. I had the advantages and disadvantages. But maybe people have questions. I see many chats. I want to think they are. I don't know what we do, Ayub, now. Please advise me as my coordinator.
Thank you very much. I think we can pause at this time to take some questions. I would like to, at the same time, welcome other teachers who are here. Mr. Wandera, I think I saw Mr. Wandera at some point. Yes, Mr. Wandera is in the room. We have a few questions which we could take.
Okay.
Bwana Charles, could you stop sharing for a moment?
Okay.
Mr. Wandera, are you in the room?
Yes, I am.
Oh, thank you. And so you're most welcome.
Thank you.
Brother has taken us through a quick overview of statistical geography, why it is important to have them, and the different kinds of statistical representations, the graphs, the charts, and as well as the maps. There are quite a number of questions, and I don't know whether you might want to jump in at this time. Some of them, brother has already handled. One question that came in is, must we leave spaces between the bars? I think he has handled that one. And then there is one here about the arrows on the axis. What is, and he's wondering, must you have the arrows? Is it a problem? What is your feeling as a teacher at this time?
Thank you. Thank you so much, Mr. Ayubu and the brother, for that elaborate sharing. Yeah, well, I want to appreciate what my brother has just put across. But I'll better defer. I hope he'll take it in very good faith. About arrows, in paper 2, we desist students from putting the arrows. Because now we shall ask you, where are those arrows pointing to? Where are they going? Because if your maximum is already 36, then why do you point the arrow? So we don't need any arrow in that. So desist from arrows. 2, about the bars. When I look at his example, is about the temperature. And then when you are drawing, you are using the bars. I'm a little confused. Which source of information you are using, brother? Bars, we usually use bars for rainfall. Rainfall are for bars. And then the temperature, it is a line, which is joined with a hand, not a ruler. And the line, the temperature line must be in the midpoint. Should not touch the vertical this side and then touch the vertical the other side. 2, I know Turan talks about bars, separating bars for rainfall. For rainfall, we accept separate bars. But to the students, for them to be so much well-versed with this, there must be simple bars must join it together up to the end.
Some sources say you have the bars separated, and then, so when do we have the bars separated and the bars together?
Maybe I have something I wanted to make a comment.
Yes.
Mr. Wandera, I want to concur with him when he says about representing temperatures using bars. We don't do it, but for this case, I just wanted only to bring data. It was the quick data that I had. If you look at some of the examples, actually it's not, and even there was some explanation which I wanted to give the student that this is not, when we are using bars, we don't use, for temperature, we don't use bars. But for purposes that we really wanted to come up, it was the quick information I have. If you look at some of the examples, we shall, in my statistics, in my paperwork, in my other lines, we have that. So I want to say that we used this for only purposes of trying to help the student understand how to draw, especially on the procedure issues. So for the other one, it's okay. For bringing in, we don't use that. But for purposes of this, we only wanted to give that. Only that to this understanding now, you are much more into the technical aspect of the student. But I wanted to use just only different. But thank you for the observation that at least you have brought it quickly to clear out, or maybe there would be issue ahead of us. Thank you.
Okay. Thank you, colleagues, for sharing. We are in the process of sharing and empowering each other. Look, I want to check if there is, so to the question of the spaces between bars.
Between the bars.
Yeah.
Okay, Turan is the author we use for statistical diagrams and the charts. He allows that. He allows living spaces between the bars. But when we come to our examining bodies here in Uganda, and more so when we are marking, most of us are well versed with the simple bars, where all the bars are joined together. So a student may fail if he separates the bars. That is according to the examining areas. And that's why I would advise students not to separate bars. Bars are only for comparatives. If you're going to separate them, then use the comparative method. Then you're able to separate them. Equal space between the bars. But if it is just a simple line graph of temperature and rainfall, please do not separate bars. Then 2, A-level statistics about the temperature and rainfall. We don't plot them the way O-level plots. So you'll have the temperature on your right, you'll have the rainfall on your right, and then you'll have the rainfall on the left, and then the temperature on the right.
Could you repeat that?
Okay, let me try to
explain.
Yes, so you try to give me the host, and then I just do something small here.
Oh, okay.
Just give me the host. Let me share something here.
As you do, there are additional questions, Brother Charles and other teachers. There was another teacher. Was it teacher Joshua? Joshua, are you a teacher? So there was about crowding the graph. Are we supposed to write the 1,000 tons with a title? Could we put those zeros alongside the title? I think the bar should be separated.
Yes, I do.
To other variables except rainfall. So we have another one which has come in as a private message that about the bars being separated. But I think that's a discussion we shall continue having. Okay, tell us a bit about the rainfall and temperature and how it is plotted in A-level.
Now, rainfall and the temperature, if you are drawing I hope you are seeing what I'm drawing.
Yes, we are.
According to Turan, you would have the temperature this side, and then the rainfall this side in millimeters. And then you plot. And if there are rainfall bars, there will be simple bars. There will be simple bars. And you shade them independently. And then you say this is January, February, March, April, May, June, July, up to December. So these are months. Let's see. Now, if you have plotted, and then also this side you have plotted. If we are drawing the temperature, we use the midpoints. Say if January was, say, let me say this was 5, 10, 15, 20, 30, okay, 20, 30, 20, this is 20, 25, then it's 30. Let me just stop there. This is, say, 10, this is 20, this is 30, this is 40, and say 50 in degrees. And we are plotting the temperature. We use the midpoint. If January had 10, if January had 10 degrees, we would plot January there, midpoint of January. If February had 30, we would go to where 30 is and plot the midpoint. If March had 40, we would go to 40 and plot the midpoint. If April had 10 still, we would go back and plot where there's 10. If May had 30, we would go back and plot where 30 is. And then if July had 40, it would be somewhere there. And then say December has 30 to be somewhere here. And then you join this with a free hand through the points. Through the points. And it becomes, it hangs this side and it hangs this side. It does not touch both axes. Now, about the title. The title, we agree two things. One, you must have the method. You must have the dependent variable, independent variable, and then the units. Now, when you decide to put the units, say thousands in the title, if it was not for this temperature and so on, then those thousands should not be put on the vertical. Because once you put them in the title and put them on the vertical, they change the units. So this will be now millions, because this times this will be now millions instead of thousands. So we do advise students to desist. Either if they put them on the title, then they shouldn't put them here. If they don't put them in the title, then they should put them here, especially if the figures are very big. Yes, Ayub.
Yes, thank you. Let me see if there are additional comments. One, I appreciate the guidance on the title. I think that answers the question this student had. There are students who are not able to see. Two things can happen. One, you might want to log off and then back in, like you have been advised by Shara, but you may also want to zoom in. So touch the screen and then use your two hands like this. You expand and then zoom in. You are able to zoom in with your phone. So try that. Okay. Does it solve it? I want to check on you guys. Does it solve it? The zooming? Okay. Olivia, I see that you have put your hand up. We're about to finish in 2 minutes. Olivia, please go ahead. Olivia, could you unmute?
Yes, do you hear me now?
Yes, we can hear you very well.
We can, yes.
Yeah, I wanted to ask a question. This where we have a scale for rainfall down. Then we have also another scale for temperature up, and we have the line graph for temperature on top of the bars. Is it only for O level or it's outdated?
Okay.
That's a good one.
Yes, that one is called the combined bar and line. I think that's what you're talking about. A combined line and the bar. Now, a combined line and bar is also, we shall also apply the same. Let me wrap this and then come back to you.
Okay.
Let's run this and then.
So Olivia, you're talking about the one where the temperature is drawn on top of the rainfall, right? And there is a line separating them.
Yes.
Okay.
Okay, let me just talk about that one briefly. Principles still remain the same. The principles still remain the same. Of course, you'll have your title. So for example, you are saying a combined bar and line graph, say showing the climate, say climate of station X and so on. That is your, then probably you have your scales, the vertical scale. You are saying 1 centimeter represents say 5 degrees. And then you also have 1 centimeter representing say 10 millimeters of rainfall. Then the horizontal scale, you are saying say 1 centimeter, this is representing 1 month. These scales are very important that you put them. You can either use words or use the ratio. Now, when you are drawing that combined, still we shall have our vertical and then have this side also the vertical. This will be your month of the year where you are going to draw your simple bars, combined simple bars. And shade them independently. And then this side we shall have the temperature. This side, sorry, we shall have the rainfall in millimeters. And then this side we shall have the temperature in degrees Celsius. So you will still, if they don't have any negative, you'll plot for temperature this side. And you'll also plot for rainfall this side. This side you use to plot the bars. This side you'll use to plot the temperature. So that if you are, I don't have an example here, but next time I think we shall provide an example. So you'll can have a line graph like that, showing the midpoints. If this is January to December, it will be like that. But I know the one that you are so much used is the one that has a freezing point. You'll have your freezing point, where you put a freezing point. This is basically, we use it for O level, where we have the freezing point. But A level, according to Turan, we don't use the freezing point here. The freezing point will be this 0. If it has negative, let me just rub off this a little. If your table has negatives, then you are simply going to create a freezing point there and plot the positives here and plot the negative down and remove this zero here and then be able to plot. You use this side to plot for the temperatures, you use this side to plot for the rainfall. And you come up with the site. This is a combined bar and line graph for temperature and rainfall.
Okay, so yeah, I think you also answered the question because someone had in the chat room, what is the type of graph that Mr. Wandera just raised? And I think you answered it. So what makes it combined? Is it the drawing of the freezing line, or is it the fact that it has the bar and then the line?
Yeah, because it is representing the rainfall and the temperature. It's representing the rainfall and the temperature. Temperatures is for using a line, and then the rainfall we are using the bars. So that's why even you see we start with the bar because the bars are plotted first, and then the line, which is plotted the next one. Some books use it as a curve.
So my title would be inaccurate if I say the combined line and bar graph.
It will not be inaccurate, but of course, one who is more correct is one who has used the combined bar and line. But the other one will also be right, because he will have started with a line and a bar. But the one who is mostly correct is one who has used the bar and line, or bar and curve. But we don't penalize. We don't penalize for that. But then they make sure that the line, the temperature line is a curve. We use a free hand to join into those points. And when you are plotting your midpoints, use dots. Midpoints, but dots. So that when you join those dots, they become a curve. Other books, I see them using X. Some use X. So when you use X, you may not get the exact point. Then you will find that some students confuse it with the physics. They even round. They keep rounding those points. This is wrong.
Yes.
And then Shamira, you have said, so teacher, the O-level approach is no longer applicable here. And then I also had another one in the chat room. Someone was saying, you said that we shade the bars independently. What if I don't shade them independently? Have I got everything wrong, or what happens?
Yes, you may not have got everything wrong, but that is the principle. The principle you shade, because each month is independent. Why do you rush to shade the whole of it like that? I see. Students are going to rush because they want to chase time, but we are looking at students who are going to work within the time frame. So this January is independent.
Olivia, you have raised your hand. Let me quickly ask, continue, Olivia.
Yeah, I wanted to ask, like he said, do you hear me?
Yes, please.
Yes, we hear you, Olivia.
Yeah, I wanted to ask, like he said, they are shed independently. What if a student is trying to shed independent and then they come up with different shadings for each bar, as in the sequence for the shading?
Of course, that one is okay. One can shade it with different, but what we are interested that the bars must be uniform. Okay, the bars must be uniform. I know of students who really want to shade each bar. Like for example, he has shaded this one like this, then he's shading this one using this side, differentiating January from February. I see. There's no penalty, but it is important to make them uniform. Okay, for time. Use uniform. Then the one of O level, of course, when we are marking, we may not penalize you. We may mark, but it is not acceptable, especially at marking level. Okay, because we expect A level students to use the one that is prescribed by Turan.
Okay,
I
thank
think
you.
yes.
Talking about shading, I have seen many students use rulers and many shade with the free hand.
Yes.
If I use a ruler or if I use a free hand, which is recommended and if I don't use the recommended one, what happens?
Remember, we are using, Mr. Ibu talked about the word tanks. Let me write it somewhere here. Tanks.
Title.
The title, the accuracy, neatness, key, and the scale. Remember, this neatness will depend on what? On how you have shaded your diagram. Now, one who has shaded using a ruler will be more neat than one who has just scratched using a free hand. We are all chasing time, but now, what exactly do we need? Who is more neater? The one who has used the ruler and the one who has used the free hand. I see. So that neatness, of course, you'll get your marker for neatness, but we are training students who are going to be perfect. We want perfect students who are going to do what is needed within the stipulated time. That's why we are timing you.
And I think it is Brother Dominic who highlighted that one single mistake can move you from an A to a C in the end. Just one slight mistake, because it eventually cascades downwards to the grade and then eventually to the final thing. So thank you. Are there other questions? Hello, teacher. I thought the word rainfall has to be below the freezing point, since it is for the bars and temperature has to be above the freezing point. I think here we still have a carryover from the O-level, but have you got the question, Robert?
Yes, I have got a question. Is now mixing the two. Let me just rub this, and then come to, let me rub this. Let me just draw two small group of bars here, just two groups, two bars, so that they're able to see what I'm talking about. I just want to draw two. There's this one, the ordinary O-level, the O-level type, where you're going to have that, then you have the freezing point. You're going to have the freezing point. Let's remove this. This is the freezing point. And you have your line, okay? And then you have your bars. Now, if it is this type, which is a combined, you are going to have your temperature here in degrees Celsius, and then the rainfall will be there in millimeters. Temperature, and then rainfall in millimeters. That is for a combined bar and line, which is O-level type. But if you are going to use the one of A-level, the one I said O-level, A-level, and it's combined, you are going to have rainfall this side, and then you are going to have temperature this side. So if it is the freezing, if it doesn't have negatives, you're going to have your freezing there. I see. And then those will be your bars.
Okay, so thank you. We are ending in 1 minute. Shamira, can you write or ask your question? We may not answer it today. We might answer it next week, but you have taken trouble to come and you have taken trouble to write it. So do you want to ask the question or do you want to write it? Shamira.
Yes, teacher.
Okay, ask your question.
Yes. Examine that.
I understand it is not to do with statistics, but could you ask it quickly?
Yes, teacher. Examine the view that the Fulani of northern region of Nigeria have the best have made the best use of their environment.
Okay, discuss the view that the Fulani of northern Nigeria have made the best use of their environment. What a way to end. Teachers, what do you think? Do you want to assist a bit to brainstorm for a minute, or do we keep that for the other week?
Okay, we can help her.
Okay.
She has already asked the question.
Mm.
The question is just about, is asking the contribution. Just about the contribution. That's why they're asking you that to what extent have the Fulanis used the best way of their environment. So which means you're going to look at the positive and negative contributions of the Fulani. But of course, you have to give the definition. You have to give the areas where the Fulanis are found, and then those examples. Then you look at the positives and negative contributions.
Okay. And the negative are mainly to do with the contribution on the environment.
The environment. These are just problems. Those are problems.
Okay. Okay, the problems resulting from the activities.
Yeah, the activities.
Okay. Shamira, are you happy?
Yes, teacher. No, teacher.
Okay, so a round of applause to our teachers today. I've seen my colleague, Mr. Musanje, is online. Mr. Musanje, say hi to everyone. Are there other teachers?
Good afternoon, Mr. Kalema.
Good afternoon, Mr. Musanje.
I'm sorry I came in a bit around 20 minutes late, but I've been on. Thank you so much for the discussion. Thank you all the rest that I've discussed. It has been nice. Hope the students have really enjoyed and have benefited. Thank you so much.
You're welcome. So allow me to thank most sincerely our lead facilitator today, our brother, Mr. Wandera, you could stop sharing, then we can spotlight brother as we thank her, as we thank him, sorry. So let's get brother on the spotlight. Okay. So Brother Charles, would like to thank you very much for today's session. I know that we put this together at almost the very last minute. It hasn't been that easy because each of us has had such a busy week, but thank you very much. And to my colleagues, Mr. Wandera, Madam, there were quite a number of other teachers who were here. Are some teachers still in? So thank you very much for being available and supporting the learners. If you have final remarks, this would be the time to make those remarks. Over to you, brother.
Thank you, Kaleman, Dr. Resta, and Mr. Wandera for the input and for the students for listening. One observation that I want to make, and I want to encourage my students. Please, there are rubrics that are required. When they tell you, if you are to do this, do it. Don't say that, now, if I don't do this, we should not think negatively, because at the end of the day, you are like you want to see. When they tell you that there is a pit, and once you move more, you will go in it, then you are saying, let me try to see. That kind of thinking at this level is, like I have said, any mark you miss at advanced level makes your grades go low, or makes you miss out an A or a B or something like that. So I'm not comfortable when students say, what if I do this? We are saying, let's do the right thing. And once you have mastered it and got it, please do it. Don't say, assuming I shed, like I have seen some students say, assuming I drop, but I don't shed. We all want to eat meat. They cannot tell you that, please go and eat meat, and you say, but are there some beans? My dear student, thank you very much, Kalem. I want to share.
So thank you. I'll share the link of the video which I have recorded, and I wish you a very good week. Next week we go back to paper 1, then we shall go to paper 2 as we move on. But Mr. Wandera would like to make some remarks. Mr. Wandera.
No, I was just saying thank you. I was just reacting to what your brother has said. I was just applauding him. Yes, I
Okay,
don't have
thank you very much, and have a good week. Bye-bye.
Uh,